Hello, good morning. Welcome to class. Today we'll be looking at integration, and our aspect for integration today is integration as reverse of differentiation. So we are going to be doing integration as the reverse of what? Differentiation. So your basic knowledge of differentiation, I just want us to go through the few examples we have here. We have these examples here to check how much you know of differentiation. So we have to find the y, the x when y equals to this. We have, for a, we have 2x cubed plus 3x minus 5. And we have to look for the y, the x. That's changing y with respect to x, if y equals to this. So in differentiation, it is a very easy thing, the most easiest I can say. So in differentiation, you take the power, which is this. Okay, take that power and multiply by any number in front of your x. So with that same number also, you take 1 out of it. So you differentiate that. So differentiating this now, I will have 3 multiplied by 2. So 3 multiplied by 2, is that okay? Then I'll have x, that same 3 minus 1. So I've differentiated the first guy. And then I move to the next one, which is 3x. If you look at x, on top of this x, there's a 1 there which we don't put. So it's going to be 3x times what? 1. So 3 times 1 is 1. Then I will have 1 minus 1. Since this does not have x, so we can't differentiate because we are differentiating with respect to x. So we only look for numbers or the values that are with x. So this becomes 0 automatically. So it's out of whatever we are doing. So I have 3 times 2x gives me 6x. 3 minus 1, 2, plus 3 times x, 1 minus 1 is 0. From your knowledge of indices, you know that any number raised to the power of 0 will be 1. So that is 3x raised to the power of 0 will give us 1, as we have 6x squared plus 3, because this becomes 1. So we've differentiated for A. Then let's move to B. Differentiating B, we have 1 over 2 x squared minus x. So what do we do? Same thing. I said you have to move this power to multiply this. And then you take a new 1 from what you have. So I have 1 over 2 multiplied by 2 x2 squared minus 1. Then minus x, that is raised to the power of 1 minus 1. So I have 1 over 2 times 2x raised to the power of 2. So 2 we cancel out. We have x2 minus 1 is 1 minus x raised to the power of 0. So x raised to the power of 1 is x minus 1. That is how to differentiate your equation with respect to x. Then let's move to the third question. For C, says x squared into x plus 1. So for the y, the x, let's expand that. X squared multiplied by x will give us x cubed. Then x squared multiplied by 1 will give me x squared. So now we are differentiating, and like I said, the 3 goes there. We have 3 times x into 3 minus 1 plus 2x into 2 minus 1. So we have 3x raised to the power of 2 plus 2x raised to the power of 1. And let's move to the final question that says x minus x raised to the power of 5 over x squared. So in this, I'm going to separate both of them. I'll have x over x squared minus x raised to the power of 5 over x squared. So if I divide this, I'll have 1 over x minus dividing this gives me x cubed. Now you can go ahead to do your divide the x of this. So divide the x of 1 over x. 1 over x can be written as x raised to the power minus 1. This is inverse of this. That gives us x minus 1 multiplied by x, then minus 1 minus 1. Okay, minus 3x 3 minus 1. So we have, on that, we have minus 1x raised to the power minus 2. Then minus 3x squared. So this gives us minus 1 over x squared minus 3x squared. So this is how to do your basics of differentiation. So move further to seeing more applications of differentiation to solving integration. So let's take a look at integration as reverse differentiation. So I will let us look at this table for your differentiating function. The first thing we have to do is multiply by the power, just like we saw in the example I gave up. Then after multiplying by the power, what do? You reduce the power by 1. Then you have the gradient function. So before integration, for the function of y is equals to whatever you're giving, you divide by the power, you increase by the power. This is how it starts. This is the gradient function. Increase by the power 1, then you divide by the power after increasing. Then you include your function. Okay, this is integration in the reverse order. But this is differentiation coming from here, your function to multiplying, then reducing, and the gradient function. For example, if I have the y, the x here, equals to x raised to the power of n, simply what we are saying in our integration as reverse, normally for the differentiation, what we do, we move this and multiply by this. No. But for integration, what I'll just do, I will increase this by 1. So my n will be increased by 1 by adding 1 to it. That's the first step in integration. Add 1 to this power of x. Then when you are done, whatever you have, which will be what? N plus 1. Then I'll divide this by what? N plus 1. Is that okay? So if you are integrating that, divide the x equals to xn, it will become xn plus what? 1 divided by n plus 1. So which is what? The opposite of our differentiation. Because if you are to differentiate that x respect to n, it gives us what? N x into what? N x into n minus 1. Right? So these are the differences between differentiation and integration. So you just look at this thing here and get to know it proper. So for this first step, increase by power of 1. Then after you are done, adding 1 to it, then you divide by the sum of adding 1, then you add your function. So this is what integration is about. It's also as easy as our differentiation. So let's look at the few examples we have here, and I'll add more other examples as we proceed. So example, we have this, we are to integrate the y dx equals to what? X over 4. I have the y, the x equals x raised to the power of 4. So in our integration, what do we do? Like I said earlier, the first step is to add 1 to your power of x. So add 1 to that. That will give us what? X raised to the power of 5. So when you are done, you divide whatever you have by 5, which is the answer of adding 1 to the value of the power. So we have differentiated that. So let's move to the next question, which says x raised to the power of minus 5. So what do we do? Add 1 to 5. So that gives us x raised to the power of what? Minus 4. Then I divide by what? Minus 4. It's very easy. So this is how to integrate, which is the opposite of all the reverse of differentiation. Then we'll move to the other one, which has the y dx is equal to what? 2 x cubed. So what do we do here? Add 1 to the power of x. It gives us 2x raised to the power of what? 4. So 2x raised to the power of 4 will give us divided by what? 4. Remember, you also divide by whatever you have by adding. Then I have 1 here, I have 2 here. So we have 1 over 2 x raised to the power of 4. So that is the differentiation for that. Then we move to the next, which is dividing x is equals to x raised to the power of minus 5. So we add 1 to the power of minus 5, which gives us x raised to the power of minus 4, and we divide this by minus 4. So I can have it as minus 1 over 4 into what? X raised to the power of minus 4. I hope you are good with that. Then the last part of it, we have the y, the x is equals to 3x into half. So what do we have? We have 3 into x half plus 1. I'm going back, so just take note, I'm going back to whatever I have there. Half plus 1. Then I have my half plus 1 gives us what? 3 over 2. So I will have 3x into 3 over 2 divided by 3 over 2. So this is what we have here. So you can divide further. So 3 divided by 3 over 2 gives us 2 times 3 into x into 3 over 2. So I have to cancel this out. I'll have 2x into 3 over 2. Just take note, our integration is not done. Something is missing. So we have to go back there and fix it. This is unlike our differentiation because I told you after everything you have to add your function. So coming back to the first question, I will have to add my c to it. Is that okay? So for every answer you get, add your c value. You add your c value to this, and you have your c value to this. You have your c value to this. So this is the difference between integration and differentiation. So just keep continuous adding of your c value to whatever answer you have gotten. Without the c, it does not depict your integration. So always remember to add the value of c to the integrand. Thank you. So let's proceed with more examples of integration. We are integrating the following. The y dx is equal to 6x plus 2x minus 3 minus 3x into half. So differentiation that, I'll bring that down. The y dx equals 6x plus 2x minus 3 minus 3x into half. So like we said earlier, the power of x in the first guy is 1. So plus 1, that gives us what? 6x raised to the power of 2, then divided by 2. Then moving to the next guy, I have 2x minus 3 plus 1. That will give us what? 2x minus 3 plus 1 gives us minus 2 divided by minus 2. We've integrated that. Then over to the last, which is minus 3x. So I have minus 3x into what? Half plus 1. Half plus 1 gives us what? 3 over 2. So we have this divided by 3 over 2. And the last guy, add your c to it. So this is what we have here. I'll have to divide this to give me 3x squared. Then minus 2 here gives me what? Minus x raised to the power of minus 2. 3 over 2. 3 divided by 3 over 2 will give us 2. So I have minus 2 x into 3 over 2 plus c. So this is what we have for integration of this. This can be written as 3x squared minus 1 over x squared minus 2x raised to the power of 3 over 2 plus c. So this is how to go about your integration. Let's move to the next question, where we have f of x is equals to what? Half x minus half, then minus 1 over 2, x minus 3 over 2. So same thing we apply to this. I will have 1 over 2, x minus half plus 1 is okay, then minus 1 over 2, x minus 3 over 2 plus 1. So let's add what we have here. I have 1 over 2 into x minus half plus 1 will give us half. So that means we'll divide this equation also by half. Okay, then we have minus 1 over 2 into x minus 3 over 2 plus 1 will give us minus 3 plus 1. That will give us minus 2 over 2. Okay, so minus 2 over 2 will give us minus 3 over 2 gives us minus 3 plus 2. Sorry, so that gives us minus 1 over 2. So I'll have here as minus 1 over 2. Okay, so this is what we have on this. Then I will have half divided by half. That is 1 over 2 times 2 over 1, which gives us 1. So I will have that as x raised to the power of half. Then minus half into what? X raised to the power of minus half, which can also be written as x raised to the power of half minus half of what? X into 1 over 2. Sorry, I have to go back to this part. I just noticed that here was not divided by half. So I will divide this by my half on this. This was not divided by the answer we have here, which is minus half. So dividing this by minus half, we have 1 over 2 times 1 over 2. That gives, divided by 1 over 2, that gives us what? 1. So on that, I will have, instead of this, I am removing that 4 plus 1 x into what? Raised to the power of minus half. Sorry for that, I didn't say that. So I have x raised to the power of 1 over 2, which will give us with x plus 1 over x raised to the power of half. So we have root x plus 1 over root x. Please include your c. I did not take this list into consideration. That is why I had to pause and go back to that. Okay, so always remember to divide by the power of your, by the power you, the addition, the sum of whatever you added to the roots. Okay, so this is why I came back to divide by half and I got this in. So this is what our answer is. So the last on that we have the x and t equals to t plus 1 squared. The x and t is equals to t plus 1 squared. So on this, I'll just have to expand t plus 1, t plus 1. So expanding t plus 1 will give us what? T squared plus t plus t plus 1. So that will give us t squared plus 2t plus 1. So now we can do the x dt. So the x dt of this, guys, gives us what? T into 2 plus 1 plus 2 into what? T, 1 plus 1. This becomes, since it's not, we don't have a T to integrate with respect to that, just like our differentiation. So differentiating this one respect to T, give us what? T. Then remember our C. So this is what we have. This divided by, we now have T raised to the power of 3 divided by 3 plus 2 raised to the power of 2 divided by 2 plus T plus C. So this gives us T over 3 plus T squared plus T plus C. So this is how to integrate this function. Then we have a question there that says when x is equal to 0, it says x is equal to 0 when t is equal to 2. So with this, I will be using this to find the value of my c. So when our x is equal to 0, you are going to say t is 2, that is 2 cubed into 3 plus 2 squared plus 2 plus c. So this gives us 0 equals to what? 8 over 3 plus 4 plus 2 plus c. So looking for the LCM of this gives us 3. This gives me 8 plus 12 plus 6. 8 plus 12 plus 6 will give us 26. We have 0 equals 26 over 3 plus c. So c becomes 0 minus 26 over 3, which is minus 26 over 3. So we'll move further to the second question that says we should look for the value of x when t equals to 3. So finding the value of x when t is equals to 3. So x when t equals to 3, I'll bring back my equation that says t cubed divided by 3 plus t squared plus t plus c. So we have t is 3, so I have 3 cubed over 3 plus 3 squared plus 3 plus our c, which is minus 26 over 3. So we have x equals 27 over 3 plus, this gives us 9 plus 3 minus 26 over 3. Looking for the lowest common multiple of this, I have 3. This gives me 27 plus 27 plus 9 minus 26. So 27 plus 27, 54 plus 9 will give me 63 minus 26 over 3. That gives us 37 by 3. 37 by 3 is 12, remainder 1 over 3. Then we have a value of our x when t is 3 as what? 12 whole number 1 over 3. So this is how to integrate and to solve for x or whatever you're looking for in your equation. Thank you. We'll have our next class dealing with further integrations and how to use that to solve your function. I hope you enjoyed the class today. So please watch more videos and keep tuned as we keep